This is the first part of a series of videos on surds. I've divided it into a lot of different parts just because surds are quite interesting to deal with, this type of numbers, and in some cases they're quite similar to the numbers you've seen before or the algebra you've done before, and in some cases they're quite different, so it might be a bit confusing. Do make sure to watch all the videos in order and to go back to a video if you don't understand. Don't move on to another video unless you've practiced the concepts that we've done. Practice the questions from your book, as it has a lot of questions in there. So for the beginning, I'm just going to quickly go through the definition of surds. Surds are numbers typically written with square roots. So something like square root of 5 or 2 square root of 10, for example. Now we have square roots such as square root of 4, square root of 36. However, these numbers do actually have an integer value. They are rational numbers, whereas square root of 5 and 2 times square root of 10 are irrational numbers. So generally, we tend to say that these are surds. Okay, so we tend to say that the square roots that are not, or expressions that have square roots that don't evaluate to a rational or an integer, are irrational numbers. However, generally in math, we tend to just refer to any of these as surds. So don't worry about the definition of surd, it's just a fancy way of saying a square root. So this is the basic definition of a surd. Now, surds, they have specific properties, and I'm going to go through these properties. I'm going to focus on 4 properties, 2 for this video and 2 for another video, and then other type of questions you might face with surds in another set of videos. So for the first property, it is interesting to note that if you square a surd, it's going to give you the integer value. So more specifically, if I have a square root of 5, let's say there are no brackets, and this square root of 5 is being squared, then this is precisely 5. Now, there are a lot of different proofs I could give you for this. One is that you could do the square and then do the square root. So I can actually do this. And I could say, well, that is 25, which is also 5. Another definition is that square roots are written as halves, that's how we write square roots. And if you wanted a cube root, then it's written as a third. So that's how we write roots as powers. So this is the square root of 5, and it's raised to the power of 2. And remember the laws of indices. If something's raised to the power, then you just multiply the power in. So I multiply these powers. A half times 2, well, that's actually just to the power of 1. So you don't need to remember these proofs. All you have to remember really is just this fact, that if you have a surd that's being squared, then you have the integer part again. Don't try to square root it. A lot of students will end up with 25, accidentally squaring the number. Don't do that. Remember that these two cancel out each other. So another example, if I have, let's say this time it's 2 square root of 5, and this is being squared. Remember that you have to spread the square root. We're still using the laws of indices, so you have 2 squared and then square root of 5 squared. Well, 2 squared is 4, square root of 5 squared, we know that that is just 5. Remember, it's just 5, it's just the integer part. It's just the value under the square root, and it is not you squaring 5. So 4, there's a multiplication here, so 4 times 5 is 20. So that's the final answer here. What if it wasn't a square root and it was a cube root? And this was also being raised to the power of 3 this time. Well, these again cancel out, and you end up with a 5. Okay, so remember these facts. Now, you won't face this as often as square root of 5, so I just put this on the side just for the sake of completion. let's say it looked slightly different. What if it was 1 over the square root of 7, and that was being squared? Then in that case, you have, again, you need to remember you spread the power to all of the numerator and denominator, so you end up with this. Well, 1 squared is just 1, and again, the square root and the power cancel out, so power of 2 cancel out, so you end up with 1 over 7. Let's say you had a 1 over, again, let's say 4 square root of 10, say this was 4 as well, squared. Again, you square root and you end up with, you spread the square, you end up with 4 squared over, this will be 4 squared as well, and then the 10 square root of 10 will be squared as well, so you end up with a 16 over 16 times, this will be 10, remember just the integer part or the value under the root, and this will be 16 over 160, or if you spotted it, this simplifies to 1 over 10, which actually we could have simplified from the beginning. So this is the first property that I've just gone through a lot of examples just to illustrate how useful this is. The other property I want to go through, which is quite an easy, simple one, is that we can treat surds, we can add and subtract surds as we do with like terms. So if I say square root of 5 plus square root of 5, well, that's 2 square root of 5s. It's just like saying x plus x, that's 2x. So adding and subtracting surds is the same as adding and subtracting like terms. Just treat the surds like you treat algebraic terms. If you had 5 square root of 3 plus 6 square root of 3, then I have 5 lots of square root of 3. I have 6 lots of square root of 3. So in total, I have 11 square root of 3s. If I had negative square root of 5 minus 18 square root of 5, then that will be negative 19 square root of 5. If I had square root of 5 minus 5 square root of 3, I can't do anything. I can't simplify this any further because they are not like terms. This is different. Square root of 5 was completely different than square root of 3. So we are treating these as like terms. So you have your like terms over here. Let's try a slightly longer one. So I'm going to put this up, do pause the video and attempt this one. So I have 5 square root of 3 minus 6 square root of 7 minus 5 plus 4 square root of 3 plus square root of 7 minus 8. Pause the video and then resume it to see how it's going to be done. So in this case, I'm going to collect the like terms. So I'm going to look at the surds. So these will be like your x, your x, your y, and z, and so on. So just treat them as so. That's why I said in the beginning, surds can be treated normally like you see in algebra, but also they have some special properties. So this will be collected with this term. So let's underline it, and then we have the square root of, the square root of 7 with another square root of 7, and then we have our normal numbers as a negative 5 and a negative 8. And if you do the simplification, remember to take the signs in front of your term. You will end up with 9 square root of 3 minus 5 square root of 7 minus 13. Do attempt more questions like these from your book. Hopefully this video was useful. If you feel confident, do move on to the next video.